This demonstration will showcase how integrating a new or existing PI system operational data infrastructure with Aviva Predictive Analytics will enable predictive asset monitoring and AI-driven anomaly detection. The following demonstration will showcase how various staff and teams can leverage Aviva's predictive monitoring solution to identify, communicate, and resolve an issue on their SAG mill before it causes any unplanned shutdown in production. In the case presented here, the monitoring and diagnostics team observes anomalous behavior and utilize predictive analytics and PI vision to identify the likely cause to be an issue on the SAG mill. They then utilize predictive analytics to perform a forecast analysis on the asset to estimate a time to failure and the urgency with which the issue needs to be addressed. Once these steps are complete, they notify the maintenance team to perform an on-site inspection and relay the forecasted urgency. Upon inspection, the maintenance team confirms the issue and are then able to identify its root cause. The maintenance team performs the prescriptive actions provided by the monitoring and diagnostics team and mitigate the issue until downtime can be scheduled to provide a fix. The monitoring and diagnostics team then confirm the prescriptive actions have addressed the issue on their end and work with the operations team to schedule downtime to implement the permanent fix. The plant manager views a dashboard providing an overview of the daily energy and production totals for the cement plant at the company's Medellin site. From this display, they also see the current totals associated with different areas of the plant, such as the mine, mill, kiln, and cement mill. They notice the mill area is blinking red, signaling a possible issue, even though the totals indicate that everything appears to be running as expected. They make a note of this and alert the monitoring and diagnostics team to investigate. To investigate further, the monitoring and diagnostics team drill down to the display showing the operational, health, and status details of the SAG mill asset. Looking under the asset status section, they observe the current operational status of the mill. Here everything appears to be in working order, with each of the sensors showing values falling within their expected range. On the left of the asset health section, they notice an increased monitoring alert state. They also see the anomaly index trend is gradually increasing. This is the predictive health score calculated within Aviva's predictive analytics. Its value is based on the amount of deviation from normal of the collective operation values of the SAG mill. The higher the value, the greater the overall deviation of one or more of its operational data points from their expected values. The monitoring and diagnostics team observe from the gauge that the current value of the anomaly index is greater than 10%, which is the highest alert threshold of the SAG mill predictive model, while the trend shows that its value has been gradually increasing over the last several hours. The bar graphs below the trend provide the top two most likely fault conditions, as determined by predictive analytics, which have led to the increased anomaly index. They observe the most likely fault is a hot lube oil supply temp, with a recent likelihood match of 99%. While a hot drive end bearing is the second most likely fault. In the sensors data section, they observe the discrepancy between the actual and predicted values of the oil reservoir temp, as well as the DE and NDE bearings. To take a closer look, they add the oil temp and its predicted value to an ad hoc display and open it. Here, they see the oil temperature has gradually been increasing, resulting in a deviation from its expected value, following a similar pattern to the anomaly index. At this point, the monitoring and diagnostics team want to dive further into the predictive behavior and fault diagnostics by navigating to the SAG mill's predictive model in Aviva's predictive analytics. Here, they view the overall model residual trend, which corresponds to the anomaly index shown in the previous display. From here, they can also directly confirm the most likely fault condition is a hot lube oil supply, as shown on the previous display as well. They also see the primary signal contributions to this fault are the drive and non-drive end bearing temperatures. Checking the trends of these bearing contributor signals, they can see that their temperatures are also increasing, consistent with the lube oil temperature increase. Diving further into this fault's details, they can see the fault's description as well as prescriptive actions the maintenance team can take to address this alert. They also view the user-defined properties, which helps the team to categorize the fault or offer additional risk analyses. Looking at the description, they learn this fault may be due to either a malfunctioning temperature control valve or possibly an issue with the lube oil cooler, and that if left unchecked, could result in a reduction of bearing life or failure. Next, the team perform a forecast analysis on one of the bearings to aid in determining the urgency needed to address this issue. The forecast model indicates the current urgency level is low to moderate, but if conditions do not change, and the bearing temperature continues to rise at this rate, it could reach possible failure temperatures within the next few days. Based on the analysis, the monitoring team immediately raise a new case and assign it to the maintenance team. Within the case, the monitoring team provide the information collected from the alert, including diagnostic details and the forecasted urgency, stating here that the issue is likely due to the elevated oil temperature. The team also start a discussion, giving everyone involved the history and progress on the resolution of the alert, and provide the maintenance team with the initial next steps to address the issue. The maintenance team will open the assigned case and add their comments after completing their on-site inspection. During the inspection, maintenance found that the radiator on the lube oil radiator cooler has fouled, and in the case discussion state that they have switched it over to run on the backup cooler. Later that day, the monitoring team confirms that the switch to the backup cooler has corrected the issue. The operating lube oil temperature has come down to the expected value, resulting in the bearing temperatures to fall to within their expected range, and confirm the anomaly index has returned to near zero. The monitoring and maintenance teams work together to find the best window for a scheduled outage of the equipment in order to complete the repairs. And once the repairs to the radiator have been completed, they fill out the resolution details within the case, such as fault condition, impact, and the related savings based on user-defined calculated estimations. The maintenance team logs that they replaced the primary cooler with its backup, and confirm that this allowed the oil and bearing temperatures to return to their normal operating range before any costly damage was caused, and without any unexpected shutdowns. The scheduled maintenance will require the maintenance team to repair or replace the primary cooler during the next outage. This will require the creation of a work order request, whose related number is entered in the case before closure.